Good afternoon, Dr. Mary. I am presenting my project, my presentation for our astronomy course. The objective for this project was I was wanting to have students create an organism that would be able to sustain itself in an ever-changing environment and have the students research and understand Earth's temperature, water, mass, and gases of both Earth and other planets, and then find the relationships between the two and see if there's any differences. So that applies to the astronomy TEKS. I also wanted them to do some research on the Big Bang Theory and do some research on the evolution of the universe. The unit topic is over evolution. I've shared with you my entry document that looks like this. I'll read some of it for you. It's fairly long, but it basically serves as the platform or the breadcrumbs for students as they venture forth and find new information over the topic. I've also created it's referred to as an answering need-to-knows. So it's an activity where students can ask their need-to-knows and venture forth and do research over their need-to-knows. And it's self-paced, and the activity provides them with information on where to go to find the research. And that where to go is on our school's library. That's the safest place for them to go. Google is not a good place. Too many research sites. And then I've created a content rubric for the project. So it's 3 pages. I'm assessing a total of, or it's worth 200 points. The kids have to create a 2D sketch. That's worth 50 points, and the criteria is found on the rubric. The students also have to put together a presentation of their liking. They could do Prezi, they could do PowerPoint, they could do a video upload. And by the way, the rubric is divided into 3 categories: unsatisfactory, proficient, and advanced. And then the last thing that the students have to produce is a physical model of their adapted or changed organism in an ever-changing world. I've put together a project calendar, so this is just a template. I'm 80% sure that it's going to change because of students' need-to-knows and what workshops they have to, or what workshops they need. This is one of the first activities that I give them, is a activity for the knows and need-to-knows. It's a way for them to create their need-to-knows for the project. Again, the breadcrumbs are found in the entry document. So I don't give them the answer in the entry document. It's kind of they have to piece together the information that I provide them and come up with a strategy on how to address it. But this activity serves as a way of communicating their need-to-knows with other groups. So the students have to write their need-to-knows on one sheet and then fold it up into a paper airplane, and they launch it several times. And as they retrieve one, they read it. They read the knows and need-to-knows. They add some more need-to-knows to it, and they'll launch it again. So it's a way of expanding their need-to-knows, getting more and more information. I have also created group roles. There are 4 group roles. There's a historian, a naturalist, an evolutionist, and an environmentalist. And the criteria for each of the group roles is found on that one document I sent you. At the end of the project, I do like for the students to assess themselves and the quality of their work. So here's a rubric of that, total of 100 points. And at METSA, the academy in which I work, Group collaboration actually weighs about 6% of their total grade. And then at the beginning of the project again, I give them a group contract, name, email, phone number, and best time to call, their strengths, their weaknesses, and how will they compensate for those weaknesses, the group roles and the responsibilities, group rules, and the group member dismissals. So for almost all my projects, I have students who write themselves up, not themselves, but they're team members, and for some projects, for some classes, they will fire a group member for not putting forth effort. So I created 3 to 5 scaffolding activities that students acquire the skills over the unit topic, evolution. One of them was on Charles Darwin. There's another activity on beak size. And there's a couple more that I've sent you. I don't want to go through it now. I don't want this to take more than 4 or 5 minutes. I know that you're a busy professor. But the entry document, the title of the project is Great Adaptation, the Uniqueness of Our Planet Earth. So the world's forests are thought to be responsible for nearly 30% of the world's oxygen turnover through the production of oxygen thanks to photosynthesis. However, both the numerous plant and animal species are rapidly disappearing due to deforestation, habitat loss, and global warming. Many species are not able to adapt fast enough when compared to the rate of changes in their habitat. The threat to different habitats like rainforests from human hands is posing new challenges for species to battle with. In fact, 50 million acres of rainforests are cut down every year, emitting 6 billion tons of carbon dioxide. But what exactly makes Earth such a special place for organisms to grow when compared to other planets in our solar system? And in bold, I have, what if you could design a new species that has better chances of surviving in an ever-changing habitat? What factors are essential to life on Earth that outside planets do and do not possess? Well, in order to answer these questions, you must also understand the development of the Big Bang Theory and the evolution of our universe, including estimates for the age of the universe. So the challenge is for the kids to design and name a new species or plant that has imaginative ways of dealing with an ever-increasing, challenging environment. Explain and give at least 4 examples of how adaptations help your organism survive in its habitat. They have to draw the sketch. You saw that on the rubric. They have to have a 2D picture of their organism showing how it adapted to its environment and how these adaptations help it survive in their selected habitat. They have to make a 3D model of the organism and then draw a 2D picture of Earth's orbit around the sun. How does Earth's composition and surface feature place it in its specific orbit around our sun? And I give them a due date of 3 weeks after the launch of a project. Most of my projects go for 3 weeks. So I hope you liked my presentation. If there are questions, feel free to email me, but I will email you later today, see if you've retrieved the YouTube account. So thank you.